Welcome to Session 20, Vertical Angles and Linear Pairs. We will build the idea visually, solve a complete example, and finish with a short independent check. By the end, you will be able to identify vertical angle pairs and adjacent linear pairs when two lines intersect. Build and solve equations from equal or supplementary angle expressions. Determine all four angles from one angle measure. Keep the diagram, the calculation, and the unit connected at every step. Start with the concept visual. The neighboring linear pair angles are supplementary. The intersecting line rules support more complex line diagrams. Read every label as evidence about what is known, what is unknown, and which measurements actually belong in the model. Here's the central reasoning. If opposite angles are labeled 3x plus 5 and 5x 35, set them equal. Solving 3x plus 5 equals 5x 35 gives x equals 20. So each vertical angle is 65 degrees and each neighbor is 115 degrees. At an intersection, opposite vertical angles are equal and neighboring linear pair angles are supplementary. These two facts turn a diagram into a small system of equations. Trust markings and stated relationships, not visual appearance. Diagrams are communication tools, but they are not guaranteed to be drawn to scale. Now add a precision check. Write each relationship beside the diagram before forming an equation: equal, complementary, supplementary, or a full turn sum. Preserve degree units, solve the algebra, and substitute the value back to confirm every angle is positive and every required total is satisfied. A complete line of work should make the diagram, formula, substitution, arithmetic, unit, and conclusion easy for another learner to audit. Use this repeatable method. First, label the four regions around the intersection in order. Second, connect opposite regions as vertical pairs. They are equal. Third, connect neighboring regions as linear pairs. They total 180 degrees. Finally, solve one relationship, then alternate the two angle values around the intersection as a check. Do not skip the final check simply because the calculator produced a number. Let us model a complete example. Two lines cross. One angle is 90 degrees. What is the vertical angle directly across from it? Step 1 is to organize the information. Label the four regions around the intersection in order. Step 2 chooses and sets up the relationship. Connect opposite regions as vertical pairs. They are equal. Step 3 carries out the mathematics. Vertical angles are equal, so the angle across from 90 degrees is also 90 degrees. A useful check is to across means equal. Next to on a line means supplementary. The answer is 90 degrees. Now verify the result against the original wording. The quantity, numerical size, and unit must all make sense together. Now it is your turn. Two angles form a straight line. One angle is 35 degrees. What is the other angle? Write a formula or relationship before calculating, then use the next 6 seconds to finish your reasoning. The model answer is 145 degrees. A linear pair adds to 180 degrees. 180 minus 35 equals 145. A useful check is to across means equal. Next to on a line means supplementary. Use this coaching check as well. Mark equal angles with matching arcs before doing algebra. The visual marks turn the diagram into an equation map. Session recap. First, label the four regions around the intersection in order. Next, connect opposite regions as vertical pairs. They are equal. Then connect neighboring regions as linear pairs. They total 180 degrees. Finally, solve one relationship. Then alternate the two angle values around the intersection as a check. A strong geometry solution is more than arithmetic. It identifies the requested quantity, represents the structure, calculates carefully, and checks the meaning of the result. Carry that full habit into the next session.